and we'll be all set with that. And it is noon in New York, 9 a.m. in LA, and top of the hour wherever you are, and time for the wonderful world of water and a pathway to energy neutrality for WRRFs, the Wastewater Resource Recovery Facilities. A really fascinating story that some of you might have heard the first chapter that I got to share with you a few years ago. And we're going to dig really deep into it in just a minute, but I just want to remind you, your mics and videos are off. We do this to protect the bandwidth of the panelists because, as I say, we often have hundreds of people who tune in, and we want to make sure you don't miss a minute of them. We also don't want to miss any questions or comments that you folks might have. And we want you to use that Q&A button. WebEx does record everything that we say and write, and that helps us to answer any questions that we can't get to at the end of the hour. We will send answers to any unanswered questions at that time, but we will at the end here answer those questions at that time. We will send a copy of the presentation, and we will send you a certificate of attendance that does give you a PDH in most states. This is for informational purposes. If you need legal advice, please go to your attorney. We're going to have actually a sustainability moment today, not so much, which is also safety for the planet, if you will. We are going to dive pretty deep into what this plan was and continues to be. And then we are going to talk, I moved too quickly there. Talk about what the plan's overview, approach, and recommendations are, some of the operational modifications, renewables, and considerations, some of the next steps, because this is not over yet. And as I said, we will have time for your questions and comments. So in terms of that sustainability moment, some things you can do to really save some energy. Decreasing the brightness of your screens can save quite a bit of energy. I think it's like 20% savings. Another thing you can do is, remember how we were told, it's going to be paperless world. We didn't ever, I don't think we're ever going to get there. But we have been saving a lot of our documents, draft after draft after draft, in digital. And if you ever looked at your hard drive or your C drive or other disks kind of areas, you're finding you're piling up so many versions. And again, you don't need that. And that's wasting energy, turns out. Please spend a little bit of time, weekly, monthly, yearly is really too long a period to go, and clean those out, delete them. Please do that. All right, now I want to introduce you to some amazing, really brilliant, and I call them, warriors of the rainbow, saviors of the planet, because these are the people who are really moving us forward in the path we have to go. Carl Lagasca is a vice president with AECOM and Envision Sustainable Professional. Over 25 years of experience in facility planning, design, services during construction, program management for water and wastewater treatment projects. He has extensive experience, and particularly with the energy-related projects for the New York City wastewater treatment facilities. He has been the design manager for the development of the New York City DEP Energy and Carbon Neutrality Plan on the New York City DEP Wastewater Resiliency Program. And he is our design manager and VP and professional engineer for the New York City DEP Energy and Carbon Neutrality Plan. Carl, thanks so much for bringing this back to us. He is joined by Robert Pape, also known as Rob, a senior technical director and technical specialist with over 34 years of experience and expertise in the wastewater industry. He has been a specialist in energy and greenhouse gas auditing, development of energy conservation measures, energy modeling, design and research and nutrient removal technologies. Mr. Pape is AECOM's biosolids and resource recovery technical practice group lead. And he has been involved in 14 New York City plants, Chicago's wastewater treatment recovery plant, and various others throughout the U.S. Thank you very much, Rob, for all of your time and energy in this particular presentation. And Melina Diaconis, civil project engineer at AECOM and Envision Sustainable Professional. She has over 15 years of experience working with multiple disciplinary teams in the tech, gas, electric, and wastewater sectors. She has the many programs, projects, construction, implementation, and she has the processes, models, tools to support the goals of corporate, municipal, institutional clients, and regulatory requirements, and has focused primarily over the last few years on climate resiliency and adaptation, energy emissions reduction, and sustainable design. Thank you all for bringing a really phenomenal presentation and the next chapter in this story of bringing New York City DEP to net zero. Really a huge accomplishment. So thank you very much. And with that, I'm going to turn this over to Carl, who's going to get us started.
Thank you, Deborah, and thank you for the kind intros for us. As many of you know, this, and Deborah mentioned this at the top of the hour, this is kind of the second or the continuation of a previous Water Wednesday the team presented back in 2022. But before we get into the start of this project, which is the New York City DEP Energy and Carbon Neutrality Plan, the team thought it might be best to really, revisit a little bit about DEP as a utility and explain how its various different sectors worked into our ECN plan. So this slide kind of gives us a nice setup of how the DEP has kind of separated itself into the various different sectors. On the right hand side, you can see that DEP spans from not just from the 5 boroughs, but all the way far up north. And DEP as a utility itself manages a very vast, complex system of water, wastewater, and stormwater infrastructure. And on the left, we see the water sector, where DEP oversees about 3 upstate watersheds that extend far north as 125 miles north. It's got 18 collecting reservoirs and delivers approximately about 1 billion gallons of water per day to New York City, to the metro areas. Now, if we shift to the right, you'll see DEP's wastewater sector, and we're zooming into the 5 boroughs now, where you'll find DEP's primary 14 in-city wastewater resource recovery facilities, or WRRFs. You'll hear them discussed as that acronym throughout the course of this presentation. And these WRRFs treat approximately about 1.31 billion gallons of wastewater that consist of both municipal sewage, stormwater, and some of the combined sewer flows as well. Now, in addition to those wastewater treatment facilities, there are about 6,000 miles of sewer pipe that runs through the 5 boroughs, 96 different wastewater pumping stations, 2 in-stream aeration facilities, and 4 major CSO retention facilities. And then in the middle, we've kind of shown some of the other sectors where DEP runs and is in charge of various office building, testing facilities, and other structures that will all sum up into about 700 different utility accounts to that span across 300 different locations or buildings. And then likewise with transportation, DEP also has its own car and marine fleets for its staff and for sludge shipping across to the different wastewater treatment facilities. Now, in addition to all these different buildings and assets, DEP also oversees the management of acres and acres of watershed, forestry, and wetlands. So what this is supposed to kind of show is how much DEP is in charge of, and what we had to grapple when producing an energy and carbon neutrality plan and all the things that came into play. So if we look at DEP and all its assets, and we want to look at its carbon footprint over the past decades, this top portion kind of shows DEP's overall carbon footprint across the entire agency and across all those sectors, summing up the carbon impact of various individual items such as the DEP's energy use, its fuel use, its greenhouse gas emissions associated with the agency's just general operation. So Now, if we just look to the left, starting in 2006, this is what our project had established as our baseline. And as you move to the right, you can see how DEP over the course of time, these several decades, has started to working on supporting carbon emissions reductions through various initiatives. And these initiatives are outlined at the bottom of the graph. These were all initiated actually in response to New York City's 2007 Plan NYC that Mayor Bloomberg had put out at that time. Now, I'm only noting a couple here of these strategic plans, some local city laws that came into effect, some other actions or specific initiatives that were instituted by the city itself or even DEP and its own bureaus. So if we kind of look in 2018, DEP knew it had to do more to bring itself down or bring down its carbon emissions. So they released a strategic plan that houses what their current energy and carbon goals are, and that is the first being a 80% greenhouse gas reductions by 2050, and you can see that in the dashed line toward the bottom in white. And then there's also an interim limit of 40% reduction by 2025, which is really just a year from now. The second goal is the agency-wide carbon neutrality goal across all the DEP sectors, the ones that I mentioned on the previous slide, and then an energy neutrality goal for all of the DEP's in-city WRFs by 2050. And that's what our project and what our presentation is going to concentrate on today. And just a reminder, these goals, again, even though they were set in 2018, they're still carrying them now. They're all based on that 2006 baseline numbers on the left-hand side. So in order to accomplish those goals, DEP knew it would be transforming itself into a utility of the future. And to do this, DEP had turned and asked AECOM to help devise an energy and carbon neutrality plan. And that is where we fit in, right in the center of that graph, highlighted in green. You could see we started work on this on 2020. I think the last presentation we did for Water Wednesday, we were showing how we were going to approach this effort. And today we're going to kind of show how some of the results and what our recommendations were. So what I'm going to do now is hand over the presentation to Robert and Melina, who led a lot of the technical work of this energy and carbon neutrality plan. Again, specifically on that wastewater sector and the contributions. What they're going to do is walk us through AECOM's approach, our decision making, the evaluations, and all the recommendations for those energy and carbon measures that were proposed for these different wastewater resource facilities. So, Rob, if you want to take us through.
Sure. Thank you, Carl. I'm gonna pick up where Carl left off. I'm gonna do a quick overview and maybe repeat some things. And then I'm gonna focus in on the approach and leave the recommendations for Melina. So what you see here is, what Carl had mentioned now in writing. On the left-hand side are the DEP objectives. And that's important because the municipality needs to come up with the, goals. And what are the goals? So we can achieve those. And in this case was 80% greenhouse gas reductions by 2050. And, to be, for other facilities, just simply go by a date. Carbon neutrality by a date, in this case, 2050, agency-wide, but energy neutrality in all city plans. So we started to look at all 14 facilities. We did it in two ways. One was individual, and the other one was a conglomerate. So we took each facility and looked at their abilities to do the three objectives individually, And then how do they sum up? Now, on the right-hand side, our initial analysis showed the carbon emissions coming from 2006. And a lot of that went into a wastewater plant. And we said, well, what could you do with that? And the yellow outlines on the purple, let me talk about the different colors. The purple is carbon that really cannot be reused. It goes to the atmosphere. On 2020, a lot of that would go to the atmosphere. And that's kind of what it's saying. But by 2050, we want to reduce it to that small amount at the bottom right-hand side. And what do we do with it? We reuse it. And we're going to focus on how to reuse it. But I'm going to focus on how this analysis occurred. So we're going to do the approach and recommendations and look at several areas that are needed to be examined when you walk into a facility. So there are 3 items: clean energy demand and production, or digester gas. Clean energy, renewables. And can a facility start to incorporate renewables, such as solar, wind, and hydro? Depending upon the size of the facility and the interest, yes, it can. On the right-hand side, on demand, there are a few things that need to be looked at. Energy conservation measure, which we will get into a little further, but state of good repair. I think that's a big item. You know, all capital projects require some change. And each capital project can tag on some energy reduction measures, you know, such as looking at the windows, looking at the roofing, insulation. There's a lot of things that can be done. And the other one is process. You want to kind of look at how your process is going. Are you over aerating? Do you have aeration? Are you doing, we'll talk about this again, but in digestion, is it aerobic or anaerobic? Anaerobic takes oxygen, uses energy. So, no, reverse it. Aerobic takes oxygen. Sorry about that. And anaerobic actually produces the methane you kind of want to use. When you start looking at your digesters, that's where the bigger hit will come. We'll talk about that. But you want to do and look at abilities in your digester. Can you co-digest? Want to, or does the municipality and local laws have the appetite for cogeneration, which means combustion on site? A combustion on site is not really being favored anymore, but there are other technologies that could be employed, such as gas to grid. And then you want to do digester improvements. How can we improve our digester? Are they well mixed? is there proper heating? You know, digester failures. At this point, you need to keep them up so you can get the gas out of them. It's probably no longer does it just mean disposal if you want to go that route. So just to reiterate and put it in priority, the digester gas production and utilization seems to be the max. You can get a lot out of that. So you want to look to increase digester gas production. You want to maximize that usage. Flaring, check your venting, and then you want to look at the carbon going through the process. Not an easy step, believe me, but all the wastewater that comes in is carbon loaded. A lot of that is going to be used up during the biological treatment to produce a quality effluent, but the remainder can definitely be reused. You want to look at the heat recovery. So again, if you're gonna your gas, you got a boiler. Let's use that to maximize the amount of heat. So you want to heat your digester and the building, and then during the summer, use that heat for cooling. But if there's excess, you could definitely find a use for that. And then optimize your process. Keep an eye on that. These are 3 objects that could generate more energy and reduce operating costs. So when we looked at all 14 plants in aggregation, we found obviously beneficial use of the ADG being the greatest amount, almost 90%. But all the other percentages, don't ignore them. You're going to need them. State of good repair, it's kind of tiny, but it could grow over time as you start to make changes, such as new buildings, new equipment and stuff like that. Renewables, definitely, if the institution is accepting that and is willing to go and say, yeah, let's get some food waste in. Definitely use renewables to increase that. And then, as I noted, process, there's a lot there. A lot of it falls on aeration. A lot of facilities seem to over aerate, but there may be reasons for that for operations. But take another look and see if that could be cut back or honed in. Use things like other instruments for testing. So, as I noted, here's the energy neutrality potential. Bowery Bay is, or for all 14 facilities, sorry. Bowery Bay is the smallest, but that's because they got rid of their digesters. The other facilities seem to almost meet the goals. You know, from let's say a little over 25% to 5%, and a few really do very well. In aggregate, they will meet the goal. However, when dealing with an individual facility, you may be anywhere from the blue to the dark blue, all through the green. So you really want to take a look and see where you land. And why do you land there? And is there any other modifications you can do? Now, this is the greenhouse gas reduction. We did a waterfall analysis. And as I'm going to just focus on the last part, it really does approach the 80%. So it indicates that the city is on the right track, and a little bit more effort will get them there. And other technologies and looking at it again will probably pull them in to meeting their goal and exceeding it. Now I'm going to turn it over to Melina, who's going to now talk about the renewables and the other technologies that can be employed.
Thank you, Rob. So I will take you through the various technologies that we did recommend through this process, including operational modifications and renewable energy, and then I will close us out with the other considerations that were taken into account. So for the operational modifications, we'll walk through each of those three different categories. We'll start with co-digestion. So co-digestion was the initial operational modification that was evaluated. And co-digestion of organic waste, which includes fats, oil, and grease or fog, with sludges. This is an increasingly common practice in water reclamation facilities in order to divert organic waste away from landfills and harness these very highly digestible wastes to increase digester gas production. Co-digestion is, these opportunities were investigated by comparing available digester capacity at each of the in-city wastewater resource recovery facilities. Those are the squares on the map, to the organic waste available. Those are the pie charts shown on the map, and that was done across all 5 New York City boroughs. So a study was performed by WRRF that determined the total tons produced by those sectors. And it's assumed that somewhere between 25 and 40% of organics produced by those sectors will be readily accessible, especially as collection efforts expand. DEP is currently coordinating receiving organics with New York Department of Sanitation, or New York Department of Sanitation, which is DSNY, as well as contract with commercial sector entities. So co-digestion is not new to DEP, actually. Their Newtown Creek facility has been accepting pre-processed food and liquid waste since 2016 from Waste Management, and they've diverted over 300,000 tons of food waste from landfills to date. However, DEP does plan to expand their receiving facilities and select 2 to 4 additional facilities across the boroughs for a consolidated acceptance plan. And this effort aligns with increasing organic collection with DSNY's citywide curbside program and new commercial rules within the city for organics. So as noted by Rob earlier, heat demand for the digesters is a significant energy demand of facilities and has subsequently also supports the generation of digester gas. So to prioritize and optimize the use of on-site resources, heat recovery technologies were evaluated in combination with digester gas use to meet the heat demand. And the intent for DEP is to completely move away from fuel oil and natural gas as heating fuels, which have higher emissions factors than digester gas, and electricity, especially as the grid is decarbonized. So while some of these technologies do generate electricity as well as heat, that wasn't the priority for this evaluation. It's important to note that where digester gas is used in boilers today, a variable portion of that is regularly sent to waste gas burners, and that flared gas is a lost energy resource. So to mitigate flaring and maximize digester gas, another beneficial use technology would need to be installed, and therefore boilers were ultimately not recommended as the primary heating application, even though they do have a high efficiency. Because of the high efficiencies and the removal of combustion emissions, heat recovery was determined to be the ideal technology option where possible. So with the priority on heat recovery technologies to meet heat demand, this allows for all the digester gas to be used for gas to grid. However, we did consider several applications for digester gas utilization. So the example that's shown here assumes about 1,000 wet tons of organics per day would be accepted in addition to the sludge. And for all applications except for combined heat and power engines, the digester gas would go through a cleaning process first. And once that digester gas is cleaned and the methane is isolated, placing the product onto the grid had the most beneficial impact on energy neutrality because there's only about a 10% loss with the technology efficiency compared to higher losses with the other technologies. If a facility cannot directly connect to the local gas grid or a neighboring user, biogenic compressed natural gas or bio-CNG is an alternative option for the clean digester gas. However, additional equipment and footprint is required to compress, store, and fill for transportation, and due to transportation, generates more emissions during its life cycle. Fuel cells, which is a comparable application to combined heat and power engines. However, it not only achieves a higher percent neutrality than CHP, it also produces less emissions because it does not utilize combustion to produce heat and electricity. Finally, biodiesel, that's currently not a viable option. However, because that technology is only in the pilot stage, as that technology evolves, it should be evaluated in the future. It does convert digester gas to biodiesel or possibly jet fuel, so there's flexibility depending on the markets. So optimization. Optimization efforts are sort of the last leg of the operational modifications, and there are three main areas where energy reduction measures are recommended to install more efficient equipment, as well as automated controls. So for aeration or secondary treatment, as existing styles of diffusers were evaluated against ultrafine bubble and membrane fine bubble diffusers. While energy reduction was the priority of this evaluation, impacts on operations were also considered. So for example, with ultrafine bubble diffusers, they're not interchangeable between manufacturers. They require going out of the country for repair and replacement. They have the highest capital cost. They're also prone to clogging, which requires regular cleaning. And we didn't expect that would actually occur from our conversations with the facilities. So while diffusers are going to be replaced, we didn't actually recommend ultrafine bubble diffusers in the future. We recommended membrane fine bubble diffusers where possible. There's also various styles of more efficient blowers that were evaluated, as well as refurbishing existing blowers. We looked at channel mixers or separate channel blowers instead of using access process air. And with the addition of automated controls, there's also the opportunity to even reduce the number of diffusers currently in the design. For lighting, using a lighting audit, we looked at fixture replacement for both interior and exterior spaces with LEDs. Those have lower power draw and a longer lifetime. There's also different types of controls that could be implemented depending on the type of area that we were looking at. Those things included standard and bi-level occupancy sensors, time of day and daylight sensors. And the bi-level occupancy sensors were something that there was interest in because they're commonly used in spaces that require emergency lighting or where there's a minimum light level that needs to be maintained. There's also the opportunity for delamping as an alternative to reduce electricity. This can occur in over-illuminated spaces, which begins with measuring light intensity of any space that's being upgraded. And finally, for pumping, initial recommendations were to select more appropriate and optimally sized pumps when upgrades are being planned. And an option for some pumping systems is to install pumps of multiple sizes to cover a range of anticipated flow rates. There's also a variable speed control to provide an opportunity for pumps to better match incoming flow rates. This minimizes pump start and stops and helps to keep the pump in a more efficient range, which reduces wear. Finally, we also explored best practices for pump maintenance and monitoring programs to manage pump efficiency through its lifetime. Finally, on optimization, there were some technology-specific options to reduce energy use and produce more digester gas and upgrade the systems. The first one, sludge thickening improvements, where separate thickening of waste-activated sludge with gravity belt thickeners. This increases the percent thickening and subsequently increases digester capacity, which then therefore increases digester gas production. Chemically enhanced primary treatment. This optimizes the carbon that's captured within the treatment process to increase digester gas production and actually decrease air requirements for secondary treatment. For facilities that have side stream treatment of centrate, an Animox-based technology was recommended for the lowest energy demand. And finally, there were several operational upgrades that are already actually in the capital plan for DEP that save energy, and those were captured in our evaluation because they haven't occurred yet. And those items that were included in the capital plan were things like more efficient HVAC systems and new digester mixers. So for renewable energy, the major energy usage in a wastewater facility is electric, and therefore any renewable power generation technology can provide a benefit to potentially offset that usage. Solar power actually has the most potential for renewable energy generation at the New York City in-city wastewater resource recovery facilities. The solar analysis that was done established boundaries of each of their 14 facilities. We identified potential locations for solar installations, categorized each of those locations from green to red, as you can see in the example here for Newtown Creek, and then we modeled potential solar energy production annually. So annual production for each of those facilities achieved anywhere from 0 to 17% of a corresponding facility's current electricity use. And those with low production potential either don't have accessible outdoor space or already have maximized their solar coverage. For example, Port Richmond, which is shown here, is one of those facilities, and they currently have about 1.85 megawatt capacity. DEP is actually planning next to add about 12 megawatts of capacity and 10 megawatts of storage at Wards Island as their next location. So for hydropower, we did explore microturbines, but there were only 3 of the 14 facilities that were identified with highest average flows and available total dynamic head to make installation viable. There's a couple of different styles of microturbines shown here for the outfall configurations of those facilities, and there are other types of styles, but these are the ones that worked with the outfalls within New York City. So any facility evaluated, you would have to kind of see which style fits with the outfall. And while microturbines should not impact the upstream treatment process, there is a risk as well as potential constructability issues to consider, especially since the hydroelectric generation that we found with these microturbines only accounted for about 1 to 3% of each facility's current electricity use. Regarding wind power, it's not expected to have a significant impact on neutrality either. There were 3 DEP facilities that within the city that were identified with the best wind patterns, and however, they have permitted height restrictions of 11 and 26 meters, which only allows for the small turbines to be installed, and they have negligible generation potential. You can see that 11 meters is fairly visible on the graph that's shown here for the Rockaway facility. However, based on other local turbine installations as precedents, Sims Metal Management in Brooklyn near the Owl's Head facility and Oak Creek Pump Station in Bayonne, New Jersey, across the channel from Staten Island, we did perform a sensitivity analysis, for single mid-sized turbines. Those are 49 meters or 160 feet. Assuming DEP could install these mid-sized turbines at the viable facilities, wind still only accounts for about 1.5% of each facility's current electricity use. With larger turbines, there is exponentially more generation potential. The large scale that's shown here is the maximum for land-based turbines in the US. So if DEP does pursue wind power, it's recommended that turbines are sized somewhere between the mid-size and large-scale turbines. However, with the extensive permitting effort that would be required, as well as the cost for the power generated, it makes these in-city projects unlikely and lower priority. So there are a number of considerations when selecting the projects to pursue that DEP needed to consider, because while they have a pathway to energy neutrality with the implementation of these recommendations, there should be a balance of risks and benefits of these recommendations. Those risks that can be defined have been incorporated based on what's known, but we can't predict how that may change. So as sea level rise, for example, the receiving water body levels may rise above affluent outfalls, and then the effluent would need to be pumped instead of flowing by gravity specifically, and that would increase energy demand. And this is not currently projected to occur within the evaluation that we did before 2050, but those models could change. And on the benefits side, there is an environmental justice impact. So wastewater resource recovery facilities are typically located in disadvantaged communities. So improvements in emissions directly improve the conditions of those neighboring communities. In addition, many of these energy control measures make these facilities more climate resilient through reduction of energy demand, generation of electricity on site, and production of renewable gas. So this study has really shifted DEP's perspective from a narrow agency-only interpretation of carbon neutrality to one that leverages DEP's unique infrastructure to help New York City as a whole decarbonize. DEP has already started implementing recommendations from the analysis that was done, particularly around maximizing co-digestion capacity and pursuing gas-to-grid projects. In fact, the organics circular economy vision that was set out in Plan NYC that Carl mentioned earlier, this builds off of this project's analysis, and it was a solid starting point to get the agencies in New York City to break down traditional operating silos. So with the analysis of work opportunities really wrapping up at this point, the Energy and Carbon Neutrality Plan is now diving into opportunities across DEP's watershed and collection system. And although these were a smaller contributor to DEP's greenhouse gas inventory in the Sankey diagram that was shown earlier, they actually may have outsized potential, especially around hydropower, forest land management, and potential heat recovery options. So thank you very much. I'm going to turn this back over to Deborah to open this up for any possible questions. Thank you.
Thank you so
Hi,
much.
Deborah. How you doing?
Wow.
I know we're
Chapter
going out
two.
of sequence here. Is it possible to go back to a slide, Deborah? Slide 17, just really quickly. I just wanted to highlight it for the group because I know it was a key point here, and I just wanted to stress, what Rob presented. This was really just a potential scenario that we've outlined for DEP, and one of the key things we, as Melina and Rob had pointed out, that those green bars at the end, these are those plants that have that ability, or we've earmarked as part of this particular scenario, being able to receive those organics and do co-digestion and be able to utilize that digester gas and bring it back to the utility grid. Jamaica and Owl's Head, although they weren't receiving organics, but they were earmarked by the DEP as being a potential location where discussions with local utilities were ongoing, where access to the grid would be accessible. And so that is what really helped pull DEP over the mark on getting to energy neutrality. Although as Rob had mentioned, that many of the plants got close or through the various different optimization or other ECMs, it was a key that all of it be looked at together. And in an aggregate, DEP was able to get up to that 118% number. And then, because we concentrated on energy here, the next slide, those greenhouse gas emissions that are associated with them help that overall span across all the sectors, which Melina had just mentioned on her last slide now, where we're moving our study into, looking outside of the WRFs and going on a broad agency-wide look to see where else we can help bring down DEP's emissions across the entire agency. And you can see a big chunk, gets reduced here just from our WRFs that gets added into the overall inventory that I'd showed previously on that carbon footprint graph. I'm sorry about that, Deborah.
Okay, that's okay. No, but this is an ongoing story, and it's a complicated story. And that's why I keep wanting you to come back and adding to it. So thank you very much. We hope we have a couple of questions here, and if you have any others, we hope you will add to it. One that I want to start with is, people always want to know this. Did costs factor into your evaluation at all?
So I'll take that, Deborah.
Okay.
Yes. So cost wasn't the priority in our evaluation. I will, note that, but we did factor it in when we compared technology alternatives. For example, I mentioned it earlier with the diffuser types, but we did look at capital and O&M costs that we considered in the selection of which were the best diffuser types. And we did that for a number of different technologies through this evaluation. However, the focus was really on what measures made it possible for New York City DEP to achieve neutrality. So it was considered, but it wasn't the overall driving factor.
And my question is, how big a factor are wastewater treatment plants and water treatment plants? I guess, we live in the water world and we think water is the most important thing in the world. But how big a factor does water have in the overall carbon scene?
Well, can I take that one, Deborah?
Please.
And
Sure.
I think this question is coming from those utilities as they sit in an overall city. Like here in New York City, the city has to run and look at its overall carbon impact and greenhouse gas reductions impact. When compared to other sectors like the transportation sectors or other stakeholders like the Department of Sanitation, the water side kind of tends to be lower than what most people expect. If there's several graphs which I can provide to the group that we looked at even when we first started this, where we saw numbers in the realm of looking at a city, the water and wastewater side attributed to maybe less than 10% of a city's energy and greenhouse gas impact. However, what's really important to note is that there is a lot of opportunity within the water sector and wastewater sector that can help a city, toward its overall goals if it's looking across all its transportations, its buildings, its other bureaus or utilities or other institutions. So even though it looks small when you look at it in the grand scheme and you pull back and look at a city, there is low-hanging fruit there that agencies and municipalities that within the water group can really focus on and help look at and bring down a city's overall greenhouse gas emissions.
Don't miss that low-hanging fruit, and don't miss those little bits, because all those tiny little bits will add up to a significant amount. And Rob made that point as well. How are you estimating fugitive emissions, and how are you planning to reduce NTO emissions? The questioner notes that his estimates based on IPCC calculations are that fugitive emissions are much larger than what you're presenting in this particular presentation.
Yes, so the DEP has their DICE inventorying program, which captures some nitrous oxide. I think that was kind of built into that question. Although nitric oxide was not the focus of this study, some of the energy recommendations didn't reflect, the changes in NTO, so to speak. However, any fuel usage changes and modifications due to some of the energy control measures, they reflect some nitric oxide impacts as, we look at those, like that question mentions, the greenhouse gas factors in determining the carbon emissions equivalents. I know DEP is doing their own separate study in parallel to this, looking at nitrous oxide. I'm not quite sure the status of that, but they've already gone into points of perhaps looking at the potentials of looking at imagery, to verify, how much is there and where it's coming from, and then how to track it from there. But that is another ongoing study that I know DEP is either commenced or in the process of starting that.
Also, do want to add though that combustion of digester gas does not really add to the CO2 balance because it's biogenic. So it actually remains in the carbon cycle for plants and all that. And so it gets rid of the anthropogenic. The amount of NO2 and SOx and NOx, not quite sure, but it really is a cleaner fuel to combust.
I do want to make mention because fugitive emissions were brought up as well in general. So what I will say in terms of the fugitive emissions estimates, DEP is actually going through as part of a sub part of this project. So we are looking at that as part of this project, but not this piece of it. How to better estimate their fugitive emissions, because your assumption that the emissions are larger than what we're showing is sort of the ongoing assumption. So we do recognize that there is that they're potentially not estimated as accurately as they need to be, but ultimately in parallel with the evaluation of how to better estimate the fugitive emissions, we're also doing work to mitigate those emissions. So the assumption is that we are doing everything. There's a number of projects that will be going forward to actually work on reducing the fugitive emissions, even regardless of whether or not the estimates of those are correct. So there's some parallel work happening there as well.
This question I may not be reading exactly. There might be, I don't know, but how much revenue are WRFs or can WRFs currently get for the RNG to the grid in the New York area?
I think I'm not quite sure if they're talking about getting a credit, perhaps, but at the moment, I think that's more of a specific DEP question that I don't think we're privy to on the cost on how what they would exchange that with.
Right. Okay. So what is biosolids management? What is the biosolids management strategy to minimize GHG emissions? And is there any biosolid incineration happening at DEP?
So so this focused really on the fence line around the treatment plants. There is a separate study, which we do have some presentations on as part of this overall global scale, that looked at the biosolids themselves and where they go. Because they move across over the fence line, they're treated on this separate study. Now, what we did there is we looked at various different technologies, various different markets, and then products that DEP could potentially pursue. So we've also created a similar plan. Not that the DEP has chosen one, but it had looked at several different items through THP, creating certain biochars, perhaps, applying them to various different land applications. So that is a study which I know is currently under review with DEP. We could talk to DEP when that's able to be shared. We've done a couple presentations through this project as well as with our partners. But essentially, not that DEP's made a decision, but we've kind of outlined that there are various different technologies, products, and markets that DEP can tap into that will have to be a whole menu item. It might not be specific one way. It could be different for every plant. There are discussions on consolidation between the plants on how they would do those biosolids management.
Was each facility evaluated independently, or did you consider any synergies when you were selecting your recommendations?
All right. No, actually, we did do synergies. The big thing was for New York City, there are 14 facilities and they share sludges between each, which can increase the amount of biogas in a particular facility or reduce it in the other ones. So we did definitely look at that. But as Carl said, in the most part, we looked at them as individual facilities. If you are an engineer or a person that's got one plant, our study definitely does cover that. But if you want to if you got more than one plant, synergy can be used. But obviously only with the biosolids, and you want to look at that.
California was supporting biogas generation and use, but now seems to be on a path to eliminate any combustible engine powered equipment in favor of solar and wind generated electricity. Are you seeing this same path in other states? Melina, you want to?
Yeah, we are seeing that here in New York as well. One of the things that I think is important to mention is while we do see that there is a path to reduce and eliminate combustion powered equipment, we're still recommending that DEP pursue generating this renewable gas and maximizing that production, because there will be some things that are very difficult and a much more longer term to actually get off of combustion-based equipment. So, for example, I mentioned that biodiesel utilization, and that's like a really good example of that. Technology is still pretty nascent, but it's something that as that technology is developed, maybe this gas becomes jet fuel and is used at a local airport down the line. So I think that there's real future there for some of those types of equipment that are going to be much longer term before they're not using combustion.
I think we have time for this one more. I think this is a Carl question. Can you talk about energy use and nutrient removal at the New York City DEP? Oh, and there's one more after that.
Well, in the analysis or DEP across its 14 plants, several of the plants are already BNR operating facilities. We, so to speak, didn't create an energy ECM about the change in converting that into a non-BNR plant into another, but we did work into, as Melina had showed in her slides, some of the operational changes associated with optimizing the BNR process, whether it's changing out the diffusers, putting more controls on the blowers, or even adding channel air, so to speak. I think were some of the key points that she mentioned. So there is, obviously significant energy use in nutrient removal and BNR process. And those were kind of massaged into as we looked at the optimization potentials or the optimization ECMs for each of the plants.
The evaluation and recommendation to switch from other fuels, i.e. natural gas, electricity, was consideration given to the overall costs and if there's economic benefit, especially as it's known natural gas is the preferred fuel utilized by power companies to generate electricity. Also, what factors were considered in determining the alternative fuel source or sources for overall cost benefits?
I think this kind of plays into the question where tapping on the grid. Well, we looked at heat recovery for a lot of the heat demands and utilizing the electrical grid for that. That is primarily because this works in two fashions. The grid here in New York City is looking to be green. I forgot there's been some initiatives to green the New York City grid and our power sources coming, so that tapping into that more greener electricity source, whether they're from the upstate wind or solar facilities, would help toward the greenhouse gas, as well as look to using air source heat pumps for the heat recovery processes, whether it's for heating buildings or heating digesters. So in tandem, they all kind of like work together to kind of push for that. So even though in trying to move away from using those carbon fuels, looking to pull the electricity from the electricity grid from those more cleaner or what we kept calling the green grid throughout this report. I don't know, Melina, were you going to say something?
Oh, I mean, I think that that's a good point, Carl, right? Is that is part of looking at alternative sources. You know, we do see pretty strong goals for New York State and New York City. And New York City has, as far as, you know, a cost is concerned for electricity, there are pretty good rates here. Now, we do expect those to go up because of the decarbonization effort. But it's still a relatively good option to pursue for the DEP.
And with that, we're going to wrap it up. I hope you'll come back. If you're not already on our mailing list, please send me a note, deborah.house@aecom.com. We're going to start a environmental, social, and governance, the ESG series, kicking it off with Will Peterson, who's recently been named to lead the ESG task force for WEF. So that should be an awesome one. That'll be in May. We haven't landed on the Wednesday in May. And Robert Spencer, who leads our global ESG efforts, will be coming back in July with the next one of those. So we're going to continue to do Water Wednesdays. We've all gotten very, very busy here at AECOM. Our clients have lots of needs, and they're keeping us very busy in the field and abroad. So, but call us, write to us, come back and see us whenever we do one of these, because we promise to bring you the best of the best. And we wish you the very best. Enjoy your spring. Get out there, smell it, feel it, walk it, and be safe every single day. And love the ones you love. Tell them how much you love them, because you never know when they might leave. I must, that's my words of safety for you and your soul. Thank you very much, Melina, Carl, and Rob, for all the effort you put into this. Thank you to all of you. Have a wonderful day. Bye.
Bye.
Deborah, did you want us to